Hey guys, this is question FM095 of the Further Maths Sharpen Study Guide. So jumping straight in, this question reads, the scatter plot below shows the number of members and distance from the city in kilometers for 20 different gyms. And then we're given this information down here. For this scatter plot, r squared is equal to 0.242. And they want us to describe the association between the variables number of members and distance from the city for these gyms in terms of strength, direction, and form. So direction, we can see that these, well actually let's start at the end. So our form is linear. It's kind of hard to tell, I guess, but there's no real curve in the data here. We can put a straight line fairly evenly through the middle of all these points of data. So we're going to call that linear. The direction we can see is negative because of this slight clustering sort of around here. We'd put a line down that way. We wouldn't put a line going up like that. So far we have negative and linear. And then in terms of the strength, to find the strength, we need to change this r squared coefficient of determination to a correlation coefficient. So to do that, we need to change our r squared into r. How we do that is we square root r squared, meaning that we square root this 0.242. Square rooting r squared is going to give us r, and square rooting 0.242 is going to give us a rounded value of about 0.492, which is under 0.5, making that a weak association. So our answer for A is going to be weak, negative. So my text is running out a bit here. Linear. So we have a weak, negative, linear association. We answer in this form because it's asked us to describe the association between the two variables in terms of the strength, direction, and form. So we make sure that we address all three: strength, direction, form. Cool, so that's part A done. Question then goes on to say for part B. Let me see if I can grab another texter. That's better. For part B, it says the mean and standard deviation of the variables number of members and distance from the city for these 20 gyms are displayed below. So part I says one of these gyms is 43 kilometers from the city. Determine the standard z-score of this gym's distance from the city. Write your answer correct to one decimal place. So the z-score formula is, of course, z equals x minus mean of x over the standard deviation of x. And in this case, we're going to be using, since we're asked to find the standard z-score of this gym's distance from the city, we're going to be using these two numbers over here because they're the mean and standard deviation to do with distance. So substituting these numbers in here, we get our actual value of x at 43 minus our mean of x we get from here is 53.6 all over, and our standard deviation is 27.6. So equating this out, it's going to be something like negative 0.384. But they want this to one decimal place, so our final answer is going to be negative 0.4. Cool. All right, on to the next question. It says, assume the number of members are approximately normally distributed. How many of these 20 gyms are expected to have a number of members that is 2 standard deviations or more above the mean? Write your answer correct to the nearest whole number. So, this is part II. So for this question, how many gyms are expected to have to have a number of members that is 2 standard deviations or more above the mean. Okay, cool. So remembering our rule for normal distributions, that's not the best, but so our 68, 95, 99.7 rule? Yeah, 99.7 rule means that we should have 68% of our data falling between the first one standard deviation above and below the mean. We should have 95% of our data falling between 2 standard deviations above and 2 standard deviations below the mean, and 99.7% of our data falling between 3 standard deviations above and 3 standard deviations below the mean. So what they're saying is how many are expected to have a number of members that is 2 standard deviations or more above the mean. So that's above this point here. Now remembering that this should encompass 95% of our data, that means that the other 5% is going to be contained from here on and from here down. So if 5% is split between these two groups, that means each of them are going to hold 2.5%. And we only want this part. So we want to find 2.5% to find our expected value. So we know that we want to find 2.5% of our 20 gyms. So if you want to do a calculation, it's 20 times 2.5%, or better written into a calculator as 20 times 0.025. And that's going to equal out to 0.5, which when we round it to the nearest whole number is 1. So one gym is expected to have a number of members that is 2 standard deviations or more above the mean, according to sort of our normal distribution rules. And then for part I, it says how many of the 20 gyms' actual number of members are 2 standard deviations or more above the mean. So first of all, we're going to want to look back here at this page and find the number of members here for the mean is 1009. So that's our mean. And that means that because our standard deviation is 546.6, we're going to go 1009 plus and then 2 times 546.6. Whack that in your calculator. Now this is going to be the value that is 2 standard deviations above. So if we grab a calculator and we go 1009 plus 2 times 546.6, comes out at 2102.2. So that would be 2 standard deviations above the mean. We can see here on our graph that there are no values that even go beyond 2000. So the actual number of gyms, which is what they're asking here, how many of the 20 gyms' actual number of members as 2 standard deviations or more above the mean? Well, there aren't any. So the actual number is equal to 0. Alright guys, that's question FM095 from the Further Maths Sharpened Study Guide done. If you have any questions about any of this, please drop them in the comments below or shoot us a message on our Facebook page, Triumph Tutoring. Shoot us a message or post something up. We'll be more than happy to help you out.